All right. Can you guys see my screen?
Yep.
Sweet. All right. So welcome. Thanks for coming, guys. Today is meeting 5, and this is a big one. So we are going to go over the challenge for the payload that you guys are going to be working on for the rest of the semester/year, and then how to break down an engineering challenge, actually parts 1 and 2. So, yeah, agenda for the night. So the first thing is going to be in challenge breakdown part 1 is first we're going to go over the details of the challenge. Then we're going to talk about goal setting, analyzing the challenge, strategizing, and feature prioritization. That's with Peyton. And then we'll be talking about the second part of challenge breakdown with Emma, which is brainstorming, decision-making tools, how to use them, what they are, decision matrices, and then integration and architecture planning. So a bunch of stuff. And then at the end of the meeting, we will split out into our teams and begin discussing, although I don't know exactly how much time we will have for that. There will be some. We'll see. So I'm going to start off with the challenge. So challenge details. So as I've told you guys before, we're going to be building a rocket payload lander challenge. What I didn't tell you before, or not directly at least, was that it is going to be a launcher challenge as well. So what you're going to be doing is designing and building a rocket payload capable of landing on the ground in the intended orientation after being ejected midair from a rocket. So the rocket's going to go up, then it's going to hit its apogee, its peak altitude, deploy parachutes, and start descending. So that's all going to be on the airframe side. You don't have to worry about that. And then at some point during the descent, the lander payload is going to be ejected from the rocket and descend to the ground under its own parachute. And you need to design a system for that payload that makes it land in the correct orientation on the ground for it to perform its secondary task, which is shooting a projectile. So it's going to have some kind of launcher that you design. What exactly, what type of launcher it is up to you guys. And it is supposed to launch a projectile as close to 15 feet from the payload chassis as possible. And there are point deductions for under and overshooting. So it's not just shoot as far as possible. It's as close to 15 feet. It's like a target distance. And I'm going to get into the details, more details of this now. So there's a bunch of constraints on the system. It's not a completely open book. These exist for a variety of reasons, and I'm going to touch on why and what these constraints are. So size, mass, interfaces, cost, the projectile itself, safety, human interaction, and then probably something else. And I'll touch on that in a bit. But this is everything we thought of now, but I admit that there might be some other things as well. So we'll start out with size and mass. These are relatively straightforward. So the first constraint is the size constraint, and that is that it must fit inside of an intro airframe rocket. The reason for this is probably relatively obvious, because if it can't fit in the rocket, it can't exactly be launched by the rocket. So just so you guys are aware, that is a 4-inch diameter rocket. So it's actually, the space that you will have to work with is actually a little bit less than 4 inches, because that's a 4-inch outer diameter. The inner diameter is minus 2 times the thickness of the body tube. We'll get you that information soon. We'll have to measure it. It's slightly different based on which vendor we use. And then it's going to be an 8-inch length. So a slightly smaller than 4-inch diameter by 8-inch length cylinder is the space you're going to be working with.
Yes, the classic engineering situation where you have metric and imperial constraints.
Shush.
Also, you might touch on this later, but it's worth pointing out that it has to come out of the rocket. So, no spikes impaled into the walls and stuff.
Yeah, please don't do that. It wouldn't work very well. And then there is a mass constraint of 2 kilograms. The reason for this is because rocket flight dynamics are affected by the weight distribution inside the rocket, both total weight and then also where that weight is, where the center of gravity is. So what I didn't write here, and probably will clarify more on later, is that the max mass is 2 kilograms, but there's actually going to be a minimum mass too, and it's actually going to be relatively close to 2 kilograms. If your design doesn't hit 2 kilos, which I don't expect to be a problem because usually, if anything, you want more mass. That's always the issue. But if somehow you make something super light, we can just add like ballast weight, like tape, like metal. We've done that before. So don't worry about the minimum too much. The next thing is interfaces. In order for this type of system to work, it needs to be able to connect to the right pieces effectively. So the first thing it needs to connect to is obviously the rocket. So there's going to be an adapter mechanism that connects the payloads to the rockets. And the plan for this is actually for this to be standardized. So all of the intro airframe rockets can work with this adapter, and all of the intro mechatronics payloads can work with this adapter. And that means that any payload could be launched in any rocket. We don't want to have them be paired together because that creates weirdness, and you'd have to vet several different versions of an adapter. And to be honest, the adapter is one of the hardest things when designing a payload to go in a rocket. We've had issues with that in the past. It's always a pain point and requires tons of testing. And since there are a bunch of you guys and a bunch of your groups and a bunch of rockets, successfully vetting a bunch of different of these would be kind of miserable and probably wouldn't happen. So we're going to standardize that, and also to allow you guys to focus on the payload side of things and allowing the airframe kids to focus on the rocket itself. The mentors are going of both mechatronics and airframe are going to co-design this and just hand it to you guys. You guys can just treat it as a black box and assume it's going to work. We will do our best. So the way that it's going to attach to your payload, so the way that you have, this is the thing you'll have to actually worry about, is there's going to be like a whole pattern. I don't know it right now. We're going to be working on that over the coming weeks, fleshing that out a little bit. But for now, you can just assume that there's going to be a mechanism that sticks on the end of your payload that you don't have to worry about it. You're just going to have to leave like a plate or something on the end there that we can attach to. And we'll tell you how you're attaching and work with you on that. There's some other small things. You have to have a pass through for a shock cord. That probably doesn't make a ton of sense to you guys right now, especially if you haven't worked with model rockets before. Basically, there's going to be a rope. It's relatively thin. That's going to have to go when your payload is inside of the rocket. It's going to have to go from one end and then past the payload up to the other side. We'll give you the sizing and dimensioning on that and give you some tips and pointers. That's a pretty common design constraint for rocket systems and honestly shouldn't be too hard. You also need to attach to a parachute unless you want your payload to just at terminal velocity fall towards the ground upon being ejected from the rocket, which I would not recommend for both your payload and your own personal safety. That would be bad. So let's not do that and have a parachute. The other main electronics, interface is electronics. We're going to standardize the battery and the main electronics board that we use just to keep things fair. And it will be something that we'll have pre-vetted. I meant to have those details squared away for you guys before this meeting, and midterms happened, so it didn't. You guys will be in a level of brainstorming over the next couple of weeks that won't require you to know what that stuff is yet. So we will make sure that we have that information to you before it becomes a design limiting factor. But do know that there will be a battery and a main board provided to you. And the last thing for electronics is have an RF transparent section for tracking transponder. What this means, that I realize that might be gibberish to some of you. So inside of both our rockets and then payloads, we try to put tracking devices that allow us to find them. Often when launches happen, especially if there's some kind of parachute malfunction that causes them to eject early, or it's very windy or something like that, the rockets and payloads can land decently far away from where you launch them. And sometimes that can go over hills or over trees or something like that and make it very hard to visually spot where they've gone, especially if there's low cloud cover that happens. So we like to put trackers inside of any individual section that's going to descend, so we can use radio to find them. What this means is you can't put the transponder inside of a metal box because radio RF waves can't get outside of a metal box. It's called a Faraday cage. And the same thing goes for if you had like a carbon fiber box. That wouldn't work either. So don't worry about that too much right now. That's not a crazy hard requirement. In your mentor will help you to make sure that that doesn't happen. So yeah, we just want to make sure we can find your stuff. The next big constraint is cost. So we're setting out 4 main categories of budget. So instead of just handing you guys a fixed budget that you can kind of spend however you want, we've kind of looked at money allocation for the project, split it between the groups, and then how we would like you guys to be spending money roughly. And to be clear, Peyton mentioned this to me before when we were prepping this actually. This is not money you guys are spending that's like yours. This is club money that we're allocating to your group, and then you can spend it on stuff for your group. But this is not like out of your pocket. This is club money. So the first main category is prototyping. So this is to buy components, hack together stuff, whatever, for developmental testing. It's not to be used on the final system. If you had something that worked particularly well that you really wanted to use on the final system, we could have a conversation about that. But the intent is not to go light on prototyping to then turn around and spend that money on actual stuff. We want you guys to be able to prototype. I realize that's difficult right now because we're not in person. A lot of that money might end up not being spent until actually that money's mostly going to be spent in the spring. But it's there for you guys when you do get to prototype. Pre-selected components is the next category. So I'm going to take a minute to explain this because it's a bit of a weird concept at first glance. So what we're going to do as a mentor team is purchase some sensors, motors, servos, that type of stuff that we've worked with before or have confidence in the specs in. And have them sitting in like a pool of communal devices. And then if you guys want to use that for your payload, what you'll do is you'll spend money to buy them. And so that will be money that will be, the price will be relatively similar to what the actual cost of the item is, but maybe not exactly. We're not going to like mess around with like tax and stuff like that. Like we'll set like, this is $70 and this is $50 and this is $30 type of thing. And so you'll use your virtual funding for that category to buy it from us. So the list of what items are on that will also be released in the next coming weeks. I don't want you guys to worry about like specific motors and stuff like that quite yet. We're going to talk about that in the next couple of weeks, and then you guys can start looking at that. And by that time, you will have that list of things. So that's the next category. The third one is custom components. So that's going to be a set amount of money that you guys will have to buy anything that's not in the pre-selected components list. So if you wanted like some hardware, materials, or some other COTS means commercial off the shelf component, then it's basically like wildcard money. And then the fourth category is projectile budget, and I'm going to get to that on the next slide. And then the last category that's not even really a category, but it's just a note, is that what isn't going to be counted against you guys if you use like printer filament, 3D printer filament, laser cutter wood, like screws, like common screws and nuts and stuff like that, from what we already have in the lab. That's not going to count against your budget. That's just kind of up for grabs for club projects to use. That's with the caveat that that's within reason. This kind of goes for all projects, that like there's an understanding of what is and isn't reasonable. You can use some stuff, and then if you use all of it, then that's starting to get unreasonable. So don't worry about that yet. Your mentors will assist you in determining if something is reasonable or unreasonable. But we just want you guys to know that in addition to the money that you're going to be given, that you will have, or the budget you'll be given, you'll have access to club resources like that. Okay, so I alluded to this earlier. The projectile is next. So the twist we're throwing on at this launcher is we're actually not giving you a projectile. You have an option, or you have the ability to design, buy, or in some way create your own projectile as long as it adheres to these certain constraints. And so figuring out exactly how you want to approach your projectile is going to be something that's up to you guys. Those constraints are pretty simple. The first is that it has to be less than $20. Please don't go buy something that's crazy expensive. That's not the intent. We're giving you some money for it so you can have some fun with it, and don't have to feel like you have to like spend the $20 on non-projectile stuff. Like, we want you guys to be creative, but it also shouldn't be crazy because it is at the end of the day a weight. The projectile has to weigh 200 grams or less. So no crazy projectiles. You can imagine that anything heavy, too heavy, would become dangerous quickly, especially because 15 feet isn't that short. And then, yeah, that's the last thing, is it needs to be deemed safe by the track lead or mentor. So if you like want to have a projectile that's like super spiky or something, if we feel like it flying through the air poses a legitimate danger to anybody, we're not going to do that. You're going to notice a theme here with the safety that we're going to emphasize. We just don't want anyone to get hurt, and we definitely don't want Northeastern mad at us about approving something that's not safe. So yeah, it's got to be safe. Oh, okay, and safety. So we're setting a rule now of no pyrotechnics, pneumatics, hydraulics, or other pressure-based systems. We do realize that there are some variants of those types of systems that are actually relatively safe. But in order to prevent an uncomfortable scenario where we have things potentially exploding, that would be really bad. And especially because these systems would perform differently on the ground versus in a rocket, for example, with vibrations and whatnot from that. So that's just not something we want to mess around with too much. So we're just gonna preemptively say that we don't want to support any systems like that. The next rule, as I alluded to earlier, is if your mentor or the track lead, myself, says that something isn't safe, it's not allowed. So, like, yeah, we want everyone to have fun, but it's not fun when people get hurt. And then the last thing is designs have to be robust enough to prevent misfires. So these things do have a decent amount of energy, and there is an acceptable level of risk. And like, that's okay as long as we're safe and not dumb around these potential energy storing devices. But the latch or whatever system is in place as the trigger needs to be robust. Human interaction. This thing needs to have, at least as of what I can think of now, 2 external buttons or switches or some device like that. One is to turn it on or off, and the other is to activate the projectile launching sequence. So the way that this is actually going to work when we do the launching is we're going to launch the rocket. It's going to go up, it's going to come down and land somewhere. And then your group and your mentor and I will travel to the location of where it has landed. We'll score we'll give it the landing score. And then we will set up the target, the 15-foot target. And at that point, a member of your group will activate the launching sequence. So it's not something that's just going to happen immediately upon hitting the ground. It's something that's going to happen with proper supervision, and you shouldn't have to like open it up to activate that. That should be something that there's an external switch of some sort. And we can talk about good ways to do that. I realize that there might be concerns about like, well, if there's a button outside or a switch outside and then it's hitting the ground, could something happen with that? I understand. So we'll come up with a solution that is robust and isn't likely to have a failure like that, because we've designed systems for this type of thing in mind. So, all right. And then I think the last thing for me is scoring. So this is how you guys are probably gonna figure out priorities and whatnot. So there's a total maximum of 300 points for performance scoring, which is like how the actual system performs on launch day. The first 100 points are for landing, and you get them if you successfully deploy from the rocket and land on the ground in an orientation that your design is designed to shoot the projectile from. So if you land and you don't like break and you're not like upside down, then you're good. You get 100 points. That might sound simple. It's not that simple. It's not insanely hard, but don't underestimate it. And then the last 200 points is for the actual launching score. So there's a formula here. Points equals mx plus b. And it is based on how close to the 15-foot target the projectile lands. So the m is the projectile mass in grams divided by 100. The x is 180 minus the distance in inches that your projectile lands from the 15-foot target. And then the b is just a flat 20 points for a successful shot. It doesn't matter where it goes. If it shoots backwards, whatever. If you successfully get your projectile to leave your payload in a reasonable shooting action, then you at least get 20 points. And just so
Wait,
you guys,
Scott.
what's up?
So if you shoot your payload 0 inches, you get 140 points.
Yeah, no, 120 points. Right?
Well, plus 20 for shooting.
100 points plus 20 for shooting.
No, isn't it? Okay. I just wanted to.
Yeah. So if you successfully shoot it at all and landed, that's 120 points.
No. 180 is much larger than the distance between your lander and the 15-foot thing.
No, it's not. It's 100. It's inches.
Oh, I'm done. Yeah, we're good.
Okay. 15 times 12 is 180. Okay. Yeah. And then you'll also get additional points potentially for the FRR. FRR is the third, and it's like the pre-flight design review in the spring. So we talked about the PDRs happening in December. That's the first one. And there will be a CDR sometime in the early spring, and then there'll be an FRR in like March or April. Yeah, I don't know exactly what the points will be for that. If there'll be points for that, don't worry about that yet. It's not like you could strategize to do well on the FRR, but not on the like launch day. Like you'll do well on the design review if you design a system that will theoretically perform well. So I wouldn't worry about it yet. I just wanted you guys to be aware that that might be there.
Scott, question.
Yeah, what's up?
Can X be negative? Because that would start to get pretty tricky if you build a launcher that does 15 feet and launches in the opposite direction.
Could X be? It will be a 15-foot ring. I'll say that. So
okay, so
it's not like you're trying to hit like a point. You're trying to hit 15 feet away. So there is like okay. I put backwards, but like there really isn't a backwards.
Okay, so any direction 15 feet is okay.
Yes.
Cool. But if you shoot 35 feet,
then you'd get negative points. So you could eat into your 20 points for shooting, if even your landing points, if you shoot it crazy far. The main reason for that rule being there is because that's not like, we're going to stand a reasonable distance away from it. So if we're going to stand like 20 feet or like 30 feet away, say, whatever it is, from a thing that's supposed to shoot 15 and then it shoots like 35 or 40 feet, like that's way more potential energy stored than was in the intent. And we don't want to encourage that. Don't shoot it crazy more than 15 feet, please. Yeah. All right. So there's just a couple other things. We are not full-time challenge or game designers, as you may have figured out. This set of rules is like, it's some of the details, but I don't pretend that there's not probably loopholes here that we didn't think of. If you find a loophole, please let us know, and we'll discuss what the intent of the rule is, potentially clarify rules. Do not just not tell us and then try to exploit said loophole, because that might lead to something that we really don't want to happen that might not be okay for a reason that you may or may not know. Regardless, I will say, if you find one, that conversation can be private. because if that is an intended possibility, then, and you don't want other teams to potentially know of this advantage that you might have just figured out, like, I totally get that. So you can message me, you can message your mentor in a PM, and that conversation can happen, and then you'll have your outcome, and then we'll go from there. So yeah, please don't think that by not asking that somehow a loophole will stay in existence that somehow would have not have. We will clarify literally all the way up until the actual launch day itself. You're not going to like get points that we didn't intend for you to get. So I've already continued to say please be safe, so you guys know. And the last thing is be fun or have fun. This was intended to be a fun challenge. It's the reason we did projectiles, because like shooting stuff is kind of fun. So yeah, it's the same reason that like building, for some of you might have built like trebuchets or something in high school. I thought that was really fun and wanted to kind of put a spin on that, but with rockets. So that is everything that I have. I'm gonna move into questions, like for a quick question section on just that, because I realized that was a lot of information. So if anyone has anything, you can put it in the chat. You can unmute and ask. Yeah. And you'll have these slides as reference. So like, don't worry if you didn't catch all of that. All right, cool. I think we're good then. And if you have questions later, like you can still ask. This is not your only opportunity to ask questions. So with that, we're going to move into challenge breakdown. I'm going to stop sharing and pass off to Peyton.
Yep. That would be me. All right. Can people see my screen all right?
Can
you see it now? Is it in presentation? Okay, so you can see it full screen. Just want to make sure.
Yes.
Cool. Yep. All right, so now that all of you are tried and true experts in SolidWorks, you've decided to completely move on from that and we'll never touch on it again. In all actuality, I think many of you might be overwhelmed with the fact that we're sort of moving on from the SolidWorks presentation portion of this and moving into the real design challenge here. I want you to rest assured, first of all, that using CAD and doing some of those design tasks is still a couple weeks out. There's a lot that I'm going to go over that actually comes before you start jumping into CAD. And the second part to that is that, that's why we have mentors with your teams, is that any of those questions that come up with CAD along the way, your mentors will be able to answer pretty quickly for you. We don't expect that you know everything about CAD or even everything that we just taught you about CAD. We're here for refreshers and everything like that. But as far as breaking down a challenge, you just saw the requirements that you have, the challenge that you have in front of you, and I think for many of you, you already have ideas buzzing in your heads for how you can do it. I know we had a quick conversation about already a rules clarification in the chat while Scott was presenting. So with respect to that, I want to actually say that we're going to slow down for a second and start to do challenge breakdown. And the reason I say challenge breakdown is when you have these ideas, you have to make sure that they're serving the purposes you want them to do. So I'm going to get into this a little bit more going forward. So the first thing when you're looking at this program in general is you want to be able to set goals, right? You could say, all right, this seems fun. I'm just going to dump time into it and not really focus on the outcome or my learning. I'm just, going to go in and enjoy it. If you read that sentence out loud yourself, like I just did, you realize it starts to sound a little bit silly, right? Why would you spend a lot of time on something where you don't really know what you're getting out of it? The second part to goal setting is you want to be realistic, right? How much experience do you currently have coming into this? How much time are you willing to put into learning and designing is also critical. I would venture to say, and the reason I put this in bold, is that that's far more important than the amount of experience that you currently have. While you can leverage previous experience with mentors at your disposal, you can pretty much catch up to any amount of learning that you want to get out of this, and any design you want to try to do if you're really willing to push enough for it. And the third bullet is, how much sleep do you really need, and or how much coffee do you have in your budget? If you're like me, that's none. If you're like Scott, that's a case of espresso double shots every week from Amazon. So, do some self-reflecting, determine what your realistic goals are, what your expectations are for yourself. The last one is ambition. This one goes hand in hand with how much time you're willing to put into it, right? There's no secret to why these mentors that are helping you out are here today. It's because we all enjoy this. We all think it's fun, and we want it to be fun for all of you. We're not here because we have to be. We're here because this is fun, and this is something that we think you'll enjoy. So, when you're setting your goals, it's important to think about, okay, how am I going to have the most enjoyment out of this? How am I going to really stretch myself to learn and to try something new? Yeah, that was the bullet that I just said. All right. So I have 3 words up here. I have what, why, and how. My portion of this presentation here today is going to be focusing on the what and the why. I'm going to specifically not talk about the how, though. For those of you who've seen Jeff Goldblum in Jurassic Park, his famous quote, "We were so busy wondering if we could do it, we never stopped and asked if we should." So you can design things that work well, are useful, and don't make the programmers that are trying to make them work sad. The key thing is, though, is that if you make something that works well but isn't useful, you didn't get very far. That's how a lot of commercial products fail, is they make a product that does something really well, but no one cares if it does that. You get, maybe in the military, you have like a counter defense measure that you engineered for an attack that is never going to happen, right? You just wasted a lot of money on that. So particularly in this challenge, what I want you to really think about is, in the early stages, determine what you want to do and why you want to do it. How are you going to maximize your score based on your goals, based on your time investment, how much you want to stretch yourself, right? And the time that we have allotted here in the fall. So what you want to start with is make sure you know the rules in and out. We have this presentation that you're all going to get access to. You can read it through. You can ask clarification questions to your mentors. Know the rules in and out. Intensely important. You can say, all right, what can I accomplish in terms of points, in terms of the milestones that you can reach? What are my restrictions, otherwise known as constraints, or something people talk about in the engineering world all the time? And you really want to just make sure that you understand these through and through, right? In this particular challenge, we have these very specifically outlined for you based on what we chose in order to make the challenge appropriately difficult. In the real world, this might manifest itself in terms of a marketing report. Maybe this is what the consumer might want, or maybe you're working contracted for the government and this is what the government has explicitly said that they want. Or maybe you're working for a med devices company and you need to make sure that your constraint is it has to be safe to be in a human body, or something like that. Understanding those critically is essential to making sure that you're going to be fine and save your Advil budget. As Scott has said, don't be the reason we make a rule. Loopholes do exist in this. We're going to emphasize that they do. Scott has already talked enough about this that I don't need to go into it. But don't be the reason we make a rule. I'm sure you've heard that before. So, yeah. So once you have the rules all sorted out, and you understand the scope and the space that you're working in, you can start to talk about the tasks. What you're going to want to do is break down each of the tasks that you can do into a list. So that is moving along the ground forward, for example, land without breaking, pick up an object off the ground, or achieve harmony with nature. Some of those are more difficult than others. And I added a note here under the first bullet that says, not the mechanisms to do them. I'm going to urge you early on in your group discussions to not talk about what your designs are going to be. your designs should be driven based on what they have to do, right? Like I said, you don't want to build a I don't want to give anyone ideas, so I won't take it for an example from this specific challenge. But you don't want to build the best vacuum cleaner ever if your job was actually to clean the desk instead of the floor, for example. So making sure to list out the actual tasks, and then you can break down those tasks in terms of how beneficial each one of them are, and how they match your goals, how reasonable they are, how exciting they are for you, and how good they are for your learning. That's essential to the point of this project. From this list that you have, right, through the strategizing, determining how important they are, you can do what's called feature prioritization. Some of you may have heard of this in different contexts, but the way that I typically operate, and a lot of the people in this club typically operate, the way the Mechatronics projects in this club have operated in the recent history, has been in need, want, nice to have lists. So what this is you break the tasks down into these three categories. The need category is, if you don't do this, your strategy that you determine that you want to do is not going to be possible. This is not the things that you think you can do reasonably. This is not the things that you want to do. These are the things that you have to do. If these list of tasks are not completed, you would consider your project as you intended it to be was a failure or failed in some capacity. Then you have your want category. These are the things that would be valuable for you to do, that you think might be reasonable for you to do, you think would benefit it, maybe a mechanism that would, or a task that if you did it would make your system more reliable, or get closer to the target, or something like that. You're not going to necessarily put these as your critical features. You're not going to design around them. Your main design is going to be focused around the needs, but you might leave yourself opportunities, like maybe a mounting hole for a mechanism that you might want to add on later, or leaving space in your design, leaving opportunities for you to implement these wants later on in your design. But these are the kind of things that if you didn't do them, your design wouldn't be a failure. It might not be as good as you think it might be able to be, but these are the kind of things that you sort of cut out as you start to run out of time. A good quote that from a mentor of mine is that everything takes twice as long as you think it's going to, even when you apply this rule to it. So that means it takes twice as long as you thought, and then once you start thinking that, it's going to take twice as long as that, and it's just going to keep compiling. You're going to end up cutting out most of your wants, but the ideal situation is to incorporate as many of them as you possibly can. Oh yeah, I forgot to put this bullet in here. Yeah, you do your wants when you want to procrastinate your homework. That's a great time to do those, but also, study, do well in school. I'm not advocating to fail. And then you have your nice to have category. This is your category that is completely non-critical to your strategy. In fact, it might not benefit your strategy very much, or it's so difficult to do that an attempt to pursue that task might completely mitigate your ability to accomplish your need and your wants. You will add it if it's nice, if it works out, if you have extra time, but you're not going to be adding a nice to have from the start, and you probably won't be considering it in your base design when you're laying out your whole system like you would for a want. Scott, it looks like you're going to say something.
Yeah, I am. Nice catch. There's actually one thing with that, or two things with that. One is that sometimes you can choose, and it may not be necessary here, but just for future reference, and you guys can choose to if you want to, there's actually a fourth category that you add, which is like a feature that you recognize you could potentially add, but you explicitly do not want to. It's like the lowest category of like, we would not, even if we had more time, consider adding it. You guys probably won't get to the end of a nice to have list anyway, so it's pretty unlikely that you would need that. But in projects that are slightly longer time scope and whatnot that I've worked on before, we've had a like not interested at all in feature that we're not even going to think about. And then the last thing I wanted to mention was that when you're talking about features, be as specific as possible. Don't be afraid to, break a feature into like multiple features if that's possible. You want to really break it into like discrete little chunks. The bigger this list is, the better off you are, and the more specific you can be about the criteria that you're designing to. So it is in your best interest to break everything into as small little units as you can, even if at first glance you don't realize that there's as many little things. This challenge, for example, may seem like there's not a ton of different things to do, but there's actually potentially more than you think.
Yeah, that's a great point. For our capstone group, when I say our, I mean me, Scott, and Bryce, as well as a few other people. We have a category that it's need, want, nice to have, and nah. And the nah is the category that is the things that we're never going to do. A good example of a breakdown for need, want, nice to have, and then like your nah category is, say you're building, and this isn't necessarily relevant to this project, but I'm saying this in terms of your future project. This isn't just the kind of thing that goes away. Is if you're making a walker robot, for example, and it needs to walk along the ground, you can have a spec for how fast it needs to walk, right? And so maybe your need is, okay, it needs to walk at all, somehow, needs to move across the ground, right? And then your want might be, all right, I want it to be able to walk at a normal human's walking speed. And then your nice to have would be, I want it to be able to walk at a normal human's running speed. And then your nah would be like, I want it to be able to run like a cheetah. Like, it's not reasonable for us to even consider that, right? Like anything beyond running like a human is completely invaluable to us in this situation. So that's just an example of how you can break it down and be specific about your tier list. Not every task is a tier. Not every spec does break down like that. Sometimes it's just, this is a need, period. Sometimes this is a nice to have, period. But it can break down nicely like that sometimes. And I think that is so the next step is brainstorming, but that's not me. Emma's going to be presenting up next about brainstorming. I actually don't have a questions slide for this section of the presentation. I'm going to take a second. I'm going to stop sharing. And if anyone has any questions, feel free to message them out. I'll just give a few seconds for this as Emma can start sharing here. All right, great. Means you all understand it perfectly. And I'm already having trouble sharing. Oh, there we go.
Everything full screen and good?
We see the presentation in Google, but not in presentation mode.
Interesting.
Also weirdly narrow and tall.
I'm not sure how that happened.
I think it's still seeing my window, not presentation mode.
Yeah.
How about now?
There you go.
Yep.
Lovely.
You're good.
Okay. Yeah, so now that you guys are all experts on breaking down challenge and prioritizing features, I'm going to explain a couple of tools that you can use to then carry that into making your decisions and going forward with the actual, to get ready to go into the actual design. So starting out with whiteboarding, not necessarily a physical whiteboard, but it's really just umbrella for all these spitballing first passes of ideas, all the crazy stuff. This is where you can get out all your stupid ideas and all the ideas that you think are stupid but are secretly great. Quantity is great in this step. Lots of brains on the problem at once to make sure you don't lose any possibilities. And then you can go later and pare down and see what is actually good. Once you've kind of gotten your ideas out, then it's a good time to start looking at what other people have done. The internet is a wonderful place, and there are a lot of designs that you can find various places, different like robotics competitions. Sometimes government and academic research can be good. We've gotten some good stuff from there. That quote at the bottom, basically just if you find something cool, don't just copy it, figure out what makes it tick, play around with a little bit, and then make it your own. Physics representations, these are a really nice way to kind of pare down an idea into maybe not a super complex mechanism, but what do you need to know to make sure it will work? Like, can you make a free body diagram to make sure you know that your spring is going to be strong enough or that this will be feasible? Getting out like all these early proof of concept math things as early as possible is really helps you not waste time making designs that are never going to work. Now for decision making, sometimes this can be the toughest part. Cornerstone reports, if you're in Cornerstone, you may have learned some of these things and thought they were stupid, but when you actually use them, they're great. So making a decision and knowing why you make it and having actual reasons instead of just, we think this will work. That's what this is all about. So decision matrices are a big one. They're the one that I found most useful. I'll go through a quick step-by-step and then show you an example. So first, you're just going to list out all the possible factors that you think matter for this. So it could be how well it works. It could be how well does it align with the goals you've talked about. Then you're going to go and rank how important they each are. And the low numbers generally just help make sure there are no weird math conflicts. And then you can go through and rate them and then multiply after so that you don't influence your ratings. And then you can just see which one numerically you should go forward with. So here is, down at the bottom, that's one example of a decision matrix that we made last year. So we went through and rated our characteristics, which you can see some of it is about like how well will it work, is it achievable, but some of it was just how excited are we about it, and that kind of stuff is very important too. Yeah, so a couple more tips. Discussion and consensus is always going to end better than just straight vote. Democracy is great, but sometimes there are better options. And then taking the time to make sure things are weighted right. There's always a healthy balance. Don't get too carried away in making sure your numbers are perfect. And then one last thing is you are a team, you're working on figuring out your team's best idea. It doesn't matter who came up with it. You'll probably forget it in a week anyway. So yeah. And then one last thing is integrating all your ideas at the end is another one of the toughest parts. So just a couple more tips for when you start looking at your design. And this is something that you'll be looking at later on, but it is nice to start thinking about really. So space claim and weight budgets space claim and weight, oh my God, both very important. If you're working on something with a bunch of different mechanisms, like maybe you have a landing system and your catapult and they both need space. And then electronics integration, once we get info on your boards and stuff, getting a spot for them. And once again, revisiting your goals and your resources often.
All right, I'm gonna pop in here. Yeah, so as some of you may or may not know, there's been a couple people that have, for various reasons, dropped the track. Just totally fine, totally get it. People get busy. Maybe we're busier than expected. But as a result of that, for now, we actually did a little bit of group reshuffling. We're going to try to avoid this as much as possible, but to give you guys the best possible experience, we might have to do it. In this case, the main difference is that there is now a group of 4 that was 2 groups of 2. Amber, Emma, Karen, and Gizem. You guys are together now, and you are sharing a mentor, or sharing mentors. Both Bryce and Peyton will be helping you guys out. The exact logistics of that is something that you guys, the 2 mentors, and then the 4 of you will figure it out. But I'm sure that will not be an issue. Bryce and Peyton have worked together plenty before, so yeah.
I don't hate Bryce that much.
So that is the way that the groups are shaking out for now. I have you guys ready to go. And actually, before I do that, are there any questions?
Will I be in a breakout room with my pod?
Yes, you will. Yeah, so actually that was one thing, is the way we're going to manage the breakout rooms. So I was intending to do the breakout rooms by team. However, I have just discovered that nobody except the host, not even co-hosts, can control breakout rooms, and I am only allowed to assign one person per breakout. Each person is only allowed to be assigned to one breakout room. So mentors would not be able to switch between their 2 groups' breakout rooms without me manually assigning them every time they want to move. Which begs the question of maybe we should not use Zoom and find a platform that does what we want. But in the meantime, while I look into that this week, maybe I'll just put you guys in
Bryce and Peyton Superpod?
I mean, we could do the Bryce and Peyton Superpod.
Yeah, that'd be fine.
Okay, Bryce and Peyton Superpod it is.
So we can probably stop the recording, right?
Yeah, I trim it after, so I'm not that worried about it. Actually,
Okay.
can you stop the recording? As a co-host, you actually can do that.
Wait, really?
Yes.
No, it's giving me an option to start the recording.
Oh, it told me it would allow you to do that. Okay, I'll stop it.